All right, this is lesson 5.9. It's about proportional relationships on graphs. We're in your notes packet on pages 17 and 18 for this one. Up at the top of page 17, you'll see a couple of reminders here. What we talked about in the last lesson, the constant of the proportion or the constant of proportionality is our unit rate. We call that K, and we get that by doing y divided by x. The relationship forms the equation y equals kx. And today we're going to put this onto a graph. So a thing to remember is that when we plot an ordered pair, it's in the order x comma y. We're going to need to know that because that'll allow us to find k values. And the other thing that we need to know is when we put a proportional relationship on a graph, it has to have two items. It has to be a straight line and it has to go through the origin. So for example 1, we have the graph here represents the cost of buying pears at a farm stand. The rate is going to tell us the y divided by the x. So the y label is the price in dollars. The x label over here is the pounds. So the unit rate tells us the dollars per pound. What we're going to do is we're going to take a look at this graph and we're going to actually select 2 points that are easily readable without us having to actually guess. So the first one that I see looks to be right here. And this point is x comma y. So this would be the point 1 comma 2. And I'm going to keep following my line basically until I see it cross over the grid one more time. And I'm going to give a little, there is one down here, but I'm going to pick this one instead. This is the point 3 comma 6. I'm just going to do it so we have a little bit more space on the graph. So we're going to take the 2 points, 1, 2, and the points 3, 6. We're going to find the k for each of those points. Remember, we find k by doing y divided by x, and in our ordered pair, they're listed out as x comma y. So for this first one, I'm going to do 2 divided by 1, y divided by x, and that gives me 2. For my second ordered pair, I'm going to do y divided by x, which will also give me 2. So are the two k values the same? Yes. What is the unit rate then? The unit rate is K, and that tells us dollars per pound. So this is $2 per pound. So it looks like the pears are being sold at $2 per pound. Looking at the graph, is the line straight? Yes. Does the line go through the origin? Origin's right here, so that's a yes. Knowing those two things are true on the graph, also knowing that our k values are the same, the graph is proportional. And we found the k value to be 2, so we can write the equation y equals 2x. It's a whole lot of pieces in one little problem here. But that's all kind of a good combination of everything that happens when we talk about constant of proportionality. Yesterday we saw it just within a chart, and now today we're taking a look at it on the graph. Example number 2. This is a grasshopper jumping. There's a couple points that are already selected for you. So the unit rate tells us the y is the feet label and x is the jump label. So how many feet per jump? We're going to pick 2 points. I'm just going to pick this first one. So this will be 1 comma 1.5. And I'm going to pick the second one, which is going to be 2 comma 3. I'm going to find the k for each of those points. So y divided by x, that's just going to be 1.5. Y divided by x, which will also be 1.5. The k values are the same. The unit rate is 1.5 feet per jump. Taking a look at the graph, is this line straight? Yes. Does it go through the origin? That's right here. Yes. So because it meets those two qualifications, yes, it's proportional. We can write our equation y equals kx. Our k value is 1.5, so we'll plug that in place of k. Example number 3. Do the points on the graph represent a proportional relationship? So interestingly enough, we don't have a line. It kind of looks visually like they might be in a line, but we're going to just pick 2 of the points. I'm going to pick these first 2 that are right here. So I'm going to do 3 and 7.8, and I'm also going to do 6 and 15.6. Finding my k value, y divided by x, and 7.8 divided by 3 is 2.6. Y divided by my x value, that's going to give me 2.6. I could also take that last point if I wanted to, 18.2 divided by 7, and that also gives me 2.6. So all the k-values here are the same for these points, which tells me that this is a proportional relationship. Now, there's no real line on the graph. I could actually draw one in, it looks like, through 0, 0, up through these points. So that tells me that yes, my line would be straight. Yes, it would go through the origin. And my equation would be y equals 2.6x. The 2.6 came from that k value that we found by doing the y divided by x values. Example 4, this is your final one for this part of the chapter. The constant of proportionality is 3. So this is k. This is crazy k. Which other points does a line representing the relationship pass through? So remember, we get k by doing y divided by x. So if we have all these different points, we just need to check them and figure out, do any of them have a k value of 3? So for the first one, I'm going to be doing 17 divided by 4. 17 divided by 4 is 4.25. That k value would not match, so it would not be on the same line. For B, I have 12.6 divided by 4.2, and I would get 3. Because the k value matches, that would be on the same line. It did say circle all that apply, so I'm not going to stop here. For C, I'm going to take my y divided by my x, and I get 2.6 repeating. That is not the same, so that would not be on my line. The final one, I'm going to take 34.5 and divide it by 11.5. And I get 3, which tells me that this would also be on the line.